Hello again, welcome to part 2 of this Flappy Bird recreation project thing with the purpose of teaching me blueprints and helping me to make my own games. Programming is kind of the one thing that's in the way of me making my own games and, you know, trying out my own ideas. Sorry for the fan noise in the background, that is noise cancellation. And big disclaimer, I still don't know what I'm doing with blueprints, so anything that I show is just stuff that works for me. I basically will just set off to try and make one thing, and I'll Google when I get stuck, and I will take things and keep things that have worked so far, and yeah, if it works I'll keep it, and I'm still learning like the best practices and the reasons why or why not to do things. So what's different here? What did we do? So you can see the counter for the points. And that works with the points. I don't know if you can see, you can probably just barely see the colliders for these points, but they get destroyed when we hit them. We have the random offset of the obstacles. Also, when we hit the wall, the point collider disappears, so you can't get a point and hit the wall at the same time. I don't know if I'm going to make like a game over screen if you get hit like the original Flappy Bird. I think I might just keep it going and maybe just take some points off and, I don't know, just play with it and see what fun stuff you can do by just staying and building up your points over time. Like, I wonder if there's something cool you could do with that. Anyway, fun to kind of experiment with. So what did we do differently this time? I have this obstacle spawner blueprint. If I double click it, the first thing I wanted to do was to get a random position in the Z so that we could spawn at all those random positions. So I needed something that was moving on Z randomly. So we have this this blueprint here, which is just, you know, default scene root and a sphere, and I can probably delete the sphere now. I think I will. There's no point for it. It's just you know, just so I can see it. Oops, sorry, wrong thing. Going back over to the event graph. So this is the code that's going on. We have event begin play going straight into this node called set timer by function name. So this was a cool find. It will basically take a function and run that function every certain amount of seconds, which is exactly what I needed. So the function name that I've got is random location Z. It's going to loop, or it's going to loop because I checked it here, and it's going to run every 1 second. And you can do other things like the start, delay, and stuff like that, but we're not using that right now. This stuff down here is just, yeah, counter debug. So I was just making a counter, making sure that this, this timer thing was actually working. So let's go into the random location Z function that I made. So I just clicked this button here and double click into this. So we start, when it's called, what happens? The first thing that happens is we're setting the vector. So I needed a vector variable. I created a vector variable which was going to act as our, it's going to contain the location of our random value every time this gets called. So we make a spawn location vector variable, and that's going to be the variable we're going to set a vector inside. We want to keep, I wanted to keep the same location where I put it in the scene and just only have the Z axis be randomized. So this position is exactly where I want it. It's off screen. So I want that X, whoa, and it's gone. I want the X and the Y to stay the same. I just want the Z to change. So X and Y we're getting from the default scene root, which is dragging, oops. There we go. We're just dragging this into here, and then we're feeding that into a get world location. So we're just getting the location of X and Y, and then we're using a random float in range to get a min and a max value, which we have made public. So we can change over here to edit the Z axis. So we set that variable, and that's that. So now we have a random location, and we're going to move that. We're going to move the object to that new location now. So set world location of this object, the target being the default scene root, and our spawn location is exactly where we want to put it. So we have the coordinates, and now we want to move it there. And then we want to spawn the moving obstacle blueprint or actor that have that's the walls, and we want to just put it in whatever the location is of this, which should be exactly the same as the spawn location, so we have that feeding into a spawn transform. Cool. So that is that. So we have it moving up and down now randomly, and then what about all the walls? So in the previous video I showed we had this one, it would move from this location to another location, and then once it reached the end it would just come right back and go. But I wanted multiple, so that wasn't going to work out very well. So that's why I resorted to doing the every second a new one gets spawned. It just means we have to set up how that gets like when it disappears, what happens then when it reaches the end. So I made a new one. I just grabbed the same stuff and then wiped everything in that, so I just kept this. I did eventually make these bigger because the tops and the bottoms were showing from the camera view. So I'm using an insert to movement again. This time I'm using 2 locations, but I'm also using the position is relative. So whenever it gets spawned, I want that location, and then I just want to move it from that location to minus 1700 in the y-axis. So wherever it starts, I want it just away in the same... Yeah, I think I explained that pretty well. So then we have the one-shot behavior type instead of the loop reset, and I think this is what we had before, reset back to start when reaching the end. So we just have one shot and it's going to stop at the end. So what's happening? Are they all just getting like stacked up at the end? No, thankfully. So in the code for this, you can ignore everything up there for now. We have this handy little function. I think I just right clicked here and did add event. Yeah, and yeah, there was on interp to stop, and yeah, just exploring what was here was cool. So I found this one. So when it stops, it just destroys itself. So poof, it's gone. And that's that. So we had everything moving pretty well, except when I was testing it, there was a problem with there was times where I would like fly up into the point collider, and there was a time or two where I flew back down back into it, so it would give me 2 points from the same collider. So I thought, I probably need to just destroy the collider once someone hits it. So that's what this was. So it started with just this bottom one. On component begin overlap from the point collider, so I just right clicked this point collider and did add event here. And we're checking if the other actor is the Flappy character. That's the name for our player character thing, object. So using casting to that, and we're checking if it's, yeah, we're checking if it's this, and if it is, I have this delay here, but I'll talk about that. If it is the other, the player character, then we want to destroy it. Pretty simple. Why do I have this delay? Well, on the character's blueprint, I have things checking for the collider's tag, and if it checks for the tag and it is that, then it's going to play a sound. It's going to print the name of it and, you know, add the counter, add the number to the counter. So without this delay, it couldn't reach. Or let's put it this way. When the character hit the collider for this and it got destroyed, it was getting destroyed before the character could check if it was what tag it was and do all that other stuff. So I had to put the tiniest delay, and maybe this isn't the best. This probably is not the best way to do this, but that's what I ended up doing. Just the fraction, the tiniest fraction of a second longer, just to give it an extra thing. Now, if this is on a low frame rate, that may not, or like, if this game was to lag behind a lot, this might be too much and then it wouldn't work. That would be funny. They couldn't get any points, but bad as well. Anyway, we could change this if we wanted to, but that works for now. So I'm also getting rid of, I'm destroying the point collider if we hit the wall colliders too. So I have these two, I'm just using the same on component begin overlap, checking if it's the character, delaying it because we still have the sound and stuff from it, which we could probably add to this, but it seems like it's more optimized if all this stuff was being calculated just the once. I don't know, maybe not. But after this gets destroyed, it's going to check, is the point collider destroyed? So this was new for me. You can take, oops, you can take this variable, or like when you get a variable, you can right click it and do convert to validated get, where if it exists still, then you can run some code. But if it doesn't exist, then yeah, if it's not valid, then you can run something else. So we're checking, has it been destroyed? And if it is still alive, if it's still valid, then we want to destroy it. I was getting some errors without this, so I originally just kind of fed it into this, but sometimes it would be like, oh no, I'm trying to destroy it, but it doesn't exist. So this fixed that. Okay, that's all there is there. Alright, so we have the random position, and once it gets spawned in that random position, it is just going to keep going, and it's going to get destroyed once it hits the end. And if the player hits the point collider, then that gets destroyed, and if it hits the wall collider gets destroyed, and the point thing. So yeah, moving on now to probably the HUD. So I created a HUD right here. Just did right click, user interface, widget blueprint, and in this HUD, very simple, it's just this text here. The most important thing that I learned though was you can check, like whenever you make like an object or something over here, you can check is variable, so then you can modify that in blueprints. So that's cool. So I named this points text and checked is variable. And now in the Flappy Bird character, or the Flappy character component, after all this stuff on the event begin play, we're gonna create this HUD widget and then display it. And then I'm going to get, or set the reference to this object, this HUD object. So then we can access the variable, this points text variable later on. So set points to text. So we're going to start with the points variable here. So this should be 0, but you know, if it needed to be a different thing, maybe we did like 100 points or something. I just kind of left this, instead of just starting at 0, I stored, yeah, I don't know, I'm kind of rambling on with that. So get the points, and we're going to convert that to a string. And this is just on play, so as soon as it begins, it's going to read 0, convert it to a string, and then we're returning the value into this set text node. And then we're also pulling this off, because it has access to our variables, we can type in points text. There we go, there's our variable, get points text, and we're going to set that. I wonder if set text, yeah, this one was a hard one. Like, this one didn't just show up for me. I don't even think that's it. See, these two are slightly different. The video I was watching used this one specifically, so that's just what I used, but you can find it if you set text, if you just write it out like that, or maybe put it in parentheses. Yeah, there we go. That's the one. Make sure context sensitive is off. I couldn't find it for a while. Anyway, so we're just setting it on play to 0. Then down here, this stuff I covered in the other video, but it's just checking if the collider that we are colliding with has a tag. So if it has a hit tag, which are the walls, then it's going to do all this stuff. But we're looking for the point tag. If it hits a point, then we want to make the sound. We're also going to print the name of the object just for debugging. Then over here we're going to take our points variable, add 1 to it, which we could probably put like a, make a variable if we want to change it to like 5 points or 100 points each. Then we could, set that, make that public. So it's adding that every time. But 1 for now. And we're setting this setting points now that it's been modified. That's our new value. And we're going to print that, convert it to a string, and then send that to the same thing as above using the HUD ref as well. So the reference to the HUD, and then get in the points text again, our variable that we made, and setting that variable to this. So it's doing that every time. Oops, sorry, I hit the microphone there. Okay, and that's really everything I've done so far. What I would like to do next probably is find a way to, I'll probably like take points away if you hit the wall for now. I don't think I want to do like a game over screen. So take points away. There's something else I wanted to do. I don't know, like I wanted to play around with materials so that, like, there's probably some like proximity thing. Okay, I'll stop. There's probably some proximity thing for when you, like, I want to make it so when you get close to the wall, like there's a radius from the ball, and if it's getting close to the ball, it like goes orange to red, to really close. It'll be red on really close, and then I don't know, that just sounded cool to me. Yeah, I don't know, it's kind of fun. I might just keep going with this. It's also set to every second. There's also a ding on every second, so I thought, okay, it's time to pull in music now. Like, I can't wait to like make music again for projects, because that's the whole that's the whole reason I got into game development. So I wanted to make games for music, and I wanted to make games for my own. Make music for my own. Sorry, make games for music. I wanted to make music for games, and I wanted to make my own music for my own games. So I had to learn how to make worlds, and now I'm learning how to do the programming. So the professional jobs helped me learn the 3D art, and working at Psionics on Rocket League is really helpful for that. Learning how, like, what goes into making a live game, and then I can come home on my time off and learn programming, and finally put my music to it and just have fun with making music and all this interactive stuff. That's really exciting for me. So anyway, since it's dinging on every second, I'm like, we gotta add some funky rhythms to this and make it seem like a song. Maybe we'll change the noise to a cowbell, or like 50 points in or something, you get the cowbell the cowbell power up or something. I don't know, but that could be fun to just experiment with that. Anyway, yeah, I'm learning a lot by just kind of playing with it, and yeah, it's exciting to see where it goes. So I guess I'll see you in the next update, whenever that is. Yeah, bye bye.